In this video, I want to take a look at algebraic fractions. So this is the second year material here on algebraic fractions for A-level maths. And in the second year material, what we're looking at is addition, subtraction, multiplication, and division of algebraic fractions. So for many of you watching this video, you probably don't even actually need this video here because you've already done this in GCSE maths. However, if you do feel like you need a bit of a refresher here and a bit of additional help on algebraic fractions, then hopefully this video will prove to be helpful. So I'm not going to go into any more detail here discussing algebraic fractions, so let's just work through some practice questions here for algebraic fractions. Starting off with question 1 here then. So we're asked to express this fraction here minus this fraction here as a single fraction in its simplest form. So because we're subtracting fractions here, I now need a common denominator. So this fraction here, because my denominator here is a quadratic, what I want to do is factorize this so I can see both of the factors. So I've got 2x minus 3. And that's all over x squared minus 3x minus 18. So factorizing this quadratic here, I'm going to get x plus 3 and x minus 6 there. Okay. And then we minus 1 over x minus 6. So I can see I've got an x minus 6 here in both of these denominators. But in this denominator here, I've got an x plus 3, and I don't have that within this fraction here. So what I need to do is times this fraction here by x plus 3, so that's both the numerator and the denominator here, to get this over a common denominator. Okay. So I get 2x minus 3 all over this. This doesn't change. X plus 3 and x minus 6. Then for this fraction here, like we said, we're going to times this now by x plus 3. So we're going to get minus 1 lot of x plus 3. And that's all over x minus 6. In fact, let me do it in order again. So x plus 3 times x minus 6 there. Okay. So now what I've got here is a common denominator. So now I can put these over one denominator here. So therefore what we have here now is 2x minus 3. I've got 2x minus 3 minus 1 lot of x plus 3. So that's minus x minus 3. Like so. That's all over now this single denominator here of x plus 3 and x minus 6. X plus 3 and x minus 6 there. So now if I simplify the numerator here, well, I've got 2x minus x, that would give me x. And I've got minus 3 minus 3, so that would give me minus 6 there. So altogether we get x minus 6. And that's all over x plus 3 and x minus 6 there. And what I notice here now is I've got an x minus 6 here in the numerator, an x minus 6 here in the denominator. So what I've got now is a common factor with the numerator and the denominator here, which I can cancel. What that leaves me with here then is 1 over x plus 3. Okay. And there we have it. So what we've done now is we've expressed this difference here as a single fraction in its simplest form. And that gives us the solution there to question 1. Moving on to question 2, now we want to express this fraction here divided by this fraction here as a single fraction in its simplest form. So because we're dividing fractions here, the first thing that I'm going to do is I'm going to take the reciprocal of this fraction. So in other words, I'm just flipping this fraction here. We then change the division to be a times, and then we perform the multiplication as usual. So because I've got 1 over 32x squared minus 2, this can be factorized, and because we're going to be times in here later on, then what I'm going to hope to do here is factorize, and then hopefully cancel down some of those factors after. So I've got 1 over, I can factor out a 2 here, so I get 2 lots of 16x squared minus 1. And hopefully you recognize we can actually factorize this further here. This is the difference of 2 squares, but we'll come back to that in a moment. Then we change the division to be a times here. And like we said, we now take the reciprocal of this fraction here, the one that we're dividing by. So we change it to a times and then flip this fraction. I've got 4x plus 1. And that's all over 2. Okay. So now, like we said, we can factorize this further here. And like we said, this is the difference of two squares. So I've now got 1 over. So I've still got two lots of this here. So I've got two lots of the difference of two squares here. So this would be 4x plus 1 times 4x minus 1. I get 4x plus 1 there and 4x minus 1. Okay. And then we times this here by 4x plus 1 over 2. So 4x plus 1 over 2 here. And now, to perform this multiplication here, what I'm going to do is I'm going to identify any common factors within this fraction here and this fraction here. And what I notice is I've got a 4x plus 1 here and a 4x plus 1 in this fraction here. We can cancel those down. So what I get left with here then is 1 over 2 lots of 4x minus 1 times 1 over 2. So now I can perform the multiplication here. In this case here then, I'm going to get 1 times 1, which is 1. So that's my numerator there. So I get 1 over. And then in my denominator here, I've got 2 lots of 4x minus 1 times by 2. So 2 times 2 is 4. I get 4 lots here of 4x minus 1 there. Okay. And notice now we have this as a single fraction in its simplest form. Obviously, no, I don't want to start explaining out any more brackets here, so it's better to leave it like this. So there we have it. So that's the solution there to question 2. Moving on to the very last question here then, where we have the function g of x, which is equal to 1 plus x plus 5 over x squared plus 4x plus 3 minus 2 over x plus 1. And here it has to show that g of x can be expressed in this form here of x plus a over x plus b, where a and b are integers to be found. So how do we answer this question here? Well, because we've got algebraic fractions here and we're adding and subtracting these algebraic fractions, we need to get everything over a common denominator. And what I also notice here is for this fraction here, the middle fraction, my denominator here is a quadratic. So if I factorize this here, I can see what my common denominator will be. Okay, so x squared plus 4x plus 3. If I factorize that here, I get x plus 1 and x plus 3. Okay, so what I can see then is I need to get everything over x plus 1 times x plus 3. So for the first number here, we can make this a fraction. So 1, if I put that over a denominator of 1 as well, so I've got 1 over 1. I need to times both top and bottom here, so both numerator and denominator, by x plus 1 and x plus 3. So we're going to get one lot of x plus 1 times x plus 3. Now for this middle fraction here, this is already over the common denominator, so it's x plus 1 times x plus 3, so we don't need to do anything with that. So I've simply got plus x plus 5. And then finally here, I've got minus 2 over x plus 1. So I've got x plus 1 here, but we don't have the x plus 3, so I need to times both top and bottom here by x plus 3. I get minus 2 lots here of x plus 3. Like so. So what I've done here is I've put everything over this common denominator already. So this is all over x plus 1 times x plus 3. Okay. Now from here, what I want to do is simplify the numerator where I can. So x plus 1 times x plus 3, well, that's just this quadratic here. And we times it by 1, so obviously I'm just going to get this quadratic again. I get x squared plus 4x plus 3. Like so. We've got plus x plus 5. And then finally here, minus 2 times x, that would be minus 2x. And then minus 2 times 3, giving me minus 6 there. Okay. And that will all be over x plus 1 times x plus 3. Like so. So now if I simplify the numerator again here, I've got x squared, I can't do anything with that. I've got 4x plus x minus 2x, that's 3x. And then finally here we've got 3 plus 5, so that's 8, minus 6 there, So that gives us 2. I've got x squared plus 3x plus 2. And that's all over x plus 1 and x plus 3. Okay. So now, because we want it in this form here, what I'm hoping is that when I factorize the numerator here, we get a common factor with the denominator, and we can cancel down where appropriate. In this case here, then factorizing the numerator here, I'm going to get x plus 1 and x plus 2, like so. And that's all over x plus 1 times x plus 3. So now I notice here that I have a common factor within the numerator and the denominator here. So we've got an x plus 1 in the numerator, an x plus 1 in the denominator here, so we can cancel those. And then finally what I get left with here is x plus 2 over x plus 3. Okay. And there we have it. So what we can see then is that a is equal to 2 and b is equal to 3. Okay. And there we have it. So that's the solution there to the very last question, question 3. And that brings the end of this video on algebraic fractions.